Hi everyone, in this video we are going to discuss significant figures, but you might hear people actually refer to them as Sig Figs. This is kind of the more common way of talking about it. You might hear significant digits, but usually that's from an older professor or someone who's a little bit more regal, and it just kind of has that flair about them. So I personally just say Sig Figs. I'm not regal at all. So Sig Figs are extremely important. We use them as scientists as a way for one person to tell another person how good of a measurement you've made. So for example, if you're trying to weigh out about a gram of sugar, we want to say, okay, I have exactly 1 gram, or maybe I have 1.5 grams. Or you could say, no, I really measured that out. I know I have exactly 1.000001 grams of sugar, or whatever it is that you're talking about. But it really is just a way to communicate from one person to another how specific that number is. So if I were to give you a definition for Sig Figs, maybe kind of an informal definition, what I would say is that it is a way to indicate the accuracy of a number. And when I say number, I really want you to be thinking measurement. Okay, there's a reason we're doing this. It's not just like we're randomly talking about numbers and we want to get together as nerds and be like, oh, that's actually 2.4. Like, that's not it. There's a reason we're doing this, and it always comes back to being in a lab and in a laboratory, okay? So let's talk about a quick example. Let's say you go to your sock drawer and you realize, okay, I have 6 socks total, all right? You have just so many socks you can't even handle it. But now I'm asking you, well, what are the colors of them? And you say, well, 5 of them are actually red. And so what you could communicate to me is that 5 out of your 6 socks are red. And so that's a really good way of communicating a number. That's very, very clear. I know 5 out of 6 are correct. But you could have also said, well, I have 0.83333 socks, and that's kind of an ugly number. I don't know why you would ever tell me that, especially because 8.333, that continues on. If you were to be completely accurate with this, you would continue to write 3s forever until the cows come home. So that's really not a good way of doing that. Someone might say, well, we could multiply it times 100, and we could say something like, all right, well, about 83% of my socks are red. You know, that's great. We could do that. But actually what we end up doing is we came up with this list of rules of a way to communicate how accurate these numbers are. So let's go through these very, very quickly. The first one is the easiest one, and it's basically that whenever you have counting numbers, and another way you could call counting numbers would be defined quantities. And so either of these, so counting numbers or defined quantities, have what we consider infinite Sig Figs. Okay, so let me just be a little bit more clear about that. So let's say I'm going to communicate to you that I have 2 dogs. I have a Rottweiler and I have a crazy dog, so there's 2 of them. But I have 2 dogs. I know that I have exactly 2 dogs at home. It's 2.00000, and I could do this forever and ever and ever because I know I have exactly 2 dogs. I don't have 2.1. I don't have 2.2. I'm not some crazy person that stores a half dog somewhere. I only have 2 dogs in my house. So that's the thing that you need to kind of keep in the back of your mind. Whenever we're talking about a defined number or a counting number, we say 2 or we say 3, but we know that we have exactly that amount. So in theory, it has a ton of significant figures in that number. Okay, so keep that in the back of your mind. Now the second part, this is the bigger rule, is that whenever we're talking about specifically with our measurements, okay, so we have measurements, I'm talking too fast. When we have different measurements, this is where we are fully applying these different rules. So the first one, this is the easiest one. Non-zero numbers are significant. Okay, so non-zero numbers, there's a very small number of them. You have 1, 2, 3, 4, 5, 6, 7, 8, or 9. That's it. Those are the only options that we have here. Those are always significant numbers. If you ever see a 3 or a 7 or a 9 or a 1, any of those numbers, they are always considered significant. Okay, that's important. But now the thing is, the one part I left out are zeros. So zeros are bitches, okay? There's no other way to put that in there. They're awful, but they are important because sometimes they're significant and sometimes they're not. So zeros are significant when ... Okay, here we go. Lots of different rules here. First one. Zeros are significant when you are between other significant numbers. Okay, so here's my example. Here's a 3, there's a 0, there's a 4. We know for sure, just because of rule A right here, the one we just did, that 3 and 4 are always going to be significant numbers. But our question is that 0 significant? Well, based on our rule that we just said here, if you have a 0 between two significant ones, that 0 is definitely significant. Okay, so that's a significant one. Rule number 2. If your 0 is to the right of a sig fig. Now there are two different things in this part. This one right here is the one that confuses all my students the most, always. This always happens, so pay attention. If you fell asleep, wake back up. There's two different cases here. So we said our 3s and our 4s are always significant, all right? But now I'm gonna write this number differently. So these numbers are the very same, but they are different because I have a decimal that I've added right there, okay? So I did draw that in there. This is not an accident. That decimal is supposed to be there. So now, if we have a 0 right here that's between the two significant numbers, based on our last rule, we already know that 0 is significant, okay? So that one's good. So now what we're trying to do is figure out if this 0 right here at the end is significant. Well, what I see here on my left example is that there is no period. There is no decimal after that 0. So that is not considered a significant figure. But here, someone has gone to great effort to distinctly draw that little decimal and make sure that we know for sure that that decimal's there, which means that that 0 is significant. Okay, so this one right here, not significant because there was no period right there. If there was that period, then it's considered significant, but it's not. So over here, we do have that decimal drawn in. That 0 is considered significant. Whew, I hope that made sense. Stay with me. We have one more rule here. Number 3. If your 0 is to the right of a decimal, but there's a little disclaimer to it, it is only significant if the sig fig is on the right. Okay, what does that mean? An example usually helps. All right, so here we go. We have 3.0000. 3 is always significant no matter what. Here's a decimal, so now we know all of these right here are going to be significant, because there's a sig fig right here, and then you have a decimal. So all of those are considered significant figures. However, if I had written 0.0003, okay, all of these are considered not significant. There's no significant figure right here that would make those decimals significant, okay? Because there's no 3, 4, 5, 6, any of those numbers, these are considered not significant. All right, so now we're going to try one more tricky one. If I did 0.0003, now I'm going to add more 0.0000. These, we all know from the last example we just did, not significant at all. They're before a significant figure, but now all of these are after the significant figure, so these zeros are considered significant. So the 3 is significant, and then all 3 of those zeros are significant. Whew, I know that's a lot. I'm so sorry. I know it's a lot, but just try to hang in there with me. So now I'm going to do one example for you. Tell me, please, how many significant figures, so how many sig figs are in, and then I'm going to give you a number right here. So here we go. 2017.00010. Okay? How many significant figures in that weird number? Go. All right, did you get an answer? Hopefully you did, but if you didn't, that's okay. Let's work through this together. The first thing that I always do when I'm trying to identify significant digits within some number is I go through and I correctly identify all of these non-zero numbers. So significant, 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 significant. That always helps me. Now, if we have a 0 between significant figures, that's always significant, so that one's good. If we have zeros after a decimal that are after significant figures, those are always significant, so those count as well. And then if you have a 0 to the right of a significant figure that is to the right of a decimal, then that is definitely significant as well. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 significant figures in that question, okay? It's a lot. This is something you absolutely have to practice, so please drill it. Do as many examples as you possibly can. All right, the last thing I'm going to leave you with is this silly little chart here called Where is the Zero? And so basically what it is something I've come up with to try to help you or guide you through how to actually determine if a zero is significant or not. So take a screenshot of this or take a picture of it and just slowly walk through it. But basically you go, okay, here's my zero. Is it to the left or the right of the decimal? If it's to the left, go to the left side. If it's the right, go to the right. And then just slowly walk through your little flow chart. I had to use burnt orange, hook 'em, in order to identify something that is considered a significant zero or what we're talking about, okay? All right, have a great week. Take care of yourself and drink water.